Hello, this is Mrs. Hickman, and today, I'm going to be going over the chain rule. Yay, chain rule. Super important. Know how to do it. If you don't get it, just keep practicing. Okay? But it all comes down to one thing, and that's composing and decomposing functions. Now, you've seen this in algebra, algebra 2, pre-cal. So now you're going to see why they were so important. Okay? So recall a composite function is substituting one function into another function. If you don't recognize what that is, you will assuredly recognize what this is. So f of g of x. Same thing. Okay? This one's just easier because you see something there. So to decompose a function, you must see a function with another function. Okay? These are usually encompassed within parentheses or under radicals. Okay? So we got a function h. Find f and g such that h of x is f of g of x. So we can assume, so it's going to be easier to find g first, and then once you take out g, replace what you took out with an x. So g, so what do you see in parentheses? Very good, x plus 1. So we take that out of here, we have f. What is f going to be? So we got something squared minus 3 times something plus 4. What is that something going to be? Well, it's just going to be x. Okay? Because see, if you were doing the composition of functions, so this is checking, where you see x, you would put g. And that's exactly what you're doing. So here I see x, I'm going to put g. So that would be x plus 1 squared minus 3 times x plus 1 plus 4. Okay? See, that's what we got. All right? So anywhere you see a parentheses, that is what g is going to be. Now let's look over here. Well, g, so parentheses or under radicals. I have a radical. What is under the radical is x cubed plus 1. So g of x is going to be x cubed plus 1. What's f going to be? Okay? Great. So I took this whole thing out, put it there. What do I put into there? Well, you put an x. Okay? So then if you did the composition right here, you would just drop this right where you see x, and you would get it. So if you know how to do this, you're already on a good way of knowing how to do the chain rule. Okay, so what a chain rule is. So we're going to be finding the derivative of functions in a function. So here we go. So if f is differentiable at the point u equals g of x, and g is a differentiable function. Differentiable means there is a limit that exists, and there's a defined point. So if they have both of this, same definition as continuity, it's going to be a differentiable function. Differentiable means it has a derivative. Then the composite function fg of x, or so you may see this, the derivative of this is going to be g prime of x times f prime of g. Okay? So, you're going to take the derivative of the inside function g of x and then multiply by the derivative of f and keep the function inside of f the same. Okay? So, for example, here you would keep this, you would leave this alone. Okay? So, you would take out this, that would be your f, and then you would do the derivative around it. Okay, let u be a function, fu, so f prime of u equals this. It's just better, it just might be easier on your eyes, that's why we're using u. Okay, remember u equals g of x. So f prime of u is going to be u prime times f prime of just this. So see, u is the same, it's just a derivative when it's in front. Other books will have this derivative at the back end. That's fine. Remember, multiply is commutative. Whatever floats your boat, whatever you want to do. I'm putting the derivative in front. Okay? So, a little bit rule. Power rule of a derivative. So, y equals u to the n. This is like x squared. So, if this was x squared, the 2x. Yeah. So, just remember. So, if y equals x squared, y prime is going to be 2x to the 2 minus 1. That's all that's saying. power chain rule. So you have y equals u to the n. So you're going to take the derivative, well, you're going to bring down the power, multiply by the derivative of that, and then whatever, this will be the thing in parentheses, then just subtract from 1, whatever's in parentheses, okay? Procedure. Decompose the function. U is going to be g of x, and we're just going to let f equal f of u. So the same thing up here, the only difference is I just made g of x u, okay? And I'm not going to be using f of x and g of x, because that's going to be look super confusing and super scary on your paper. But I guess it can make it look smarter as long as it's clear, okay? But you're already smart because you're in calculus. Way to go. Congratulations. All right, so procedure. So decompose and then take the derivative of each. Oh, look, here's an example. Now things are going to come together. All right, so first thing, what's in parentheses? All right, whatever is in parentheses is going to be my u. Okay, so I'm just going to put the u right here, x squared minus x plus 1, and f of u. Okay, well, that's easy. So f, so remember, if I take this out, and this is going to be equal to u, I'm going to have something to the 23rd. Okay, u equals this. So this is going to be u. Okay. Now we're going to take the derivatives of both. So u prime is going to be 2x minus 1. F prime of u is going to be 23 u to the 22nd. Okay. Now we're going to be finding the derivative of this. F prime of x is going to be, where's that derivative? Where's that derivative? Okay, we're looking here. U prime. So u prime is this. U prime, but we're also doing the power rule if you want to put this 23. We'll just do it like this. U prime times f prime of u. Okay? If you want to, you could add an extra step here. If you want to do like f prime of x, that would be 23 x squared plus x plus 1 to the 22nd. You could also do that too. I'll do that on the next one. I'm just wanting to go with this so you don't get confused. So 23 times 2x minus 1 times u to the 22nd. U is this thing. Okay, there you go. That is the chain rule. Okay, usually with these you're going to leave things in factor form because when you get to graphs and stuff, you're going to be wanting to find 0. So it's just best to keep things in factored form. So we're just going to let that alone. If you want to, you could divide, multiply by, distribute here. Up to you. Okay, your next example. U is going to be what's underneath the radical. I like to do a little indentation here too, so it separates you from this derivative and that derivative. So u is going to be negative 2x to the 4th plus 5. F of u is then going to be, so put u here, and then this is to the 4th power. Now it's probably going to help you to go ahead and write this as u to the 1/4. U prime is going to be negative 8x cubed. F prime of u is going to be 1/4 u. 1/4 minus 1, so that's going to be minus 4/4. You're going to get really good with fractions here. 1/4 u to the negative 3/4. Okay, If you want to, you can add an extra step, which is going to be f prime of x. It's going to be a separate f prime of x than that one. Okay? It's going to be 1/4. U is negative 2x to the 4th plus 5 to the negative 3/4. Okay, so when you find your derivative now, you're going to have negative 8x cubed times 1/4 times negative 2x to the 4th plus 5 to the negative 3/4. Okay. I'm going to go to multiply this because it's easier, because it looks nicer. Negative 8 times 1/4, that's going to give you negative 2. And this is a negative exponent, so this is going to go in the bottom. I'm going to do that in the next step. Your final answer is going to be negative 2x cubed over negative 2x to the 4th plus 5 equals 3 to the 4th. And if you really love algebra, you can take it one step further and write it like that. Okay. So for my students, I would probably be fine if you stopped here. Okay. So because you're going to, when we get to the graphs and stuff, you're going to want this, you're going to have to write it in the bottom. Okay. Next example. So here, getting little things complicated. You can remember, we have something times something. What is that called? That is called the product rule. Okay. Review of the product rule. D over dx. Actually, d over dx of fg is f prime of g plus g prime of f. Okay, that's the product rule. We're going to go to that later. So, when you do chain rule, you need to have organization going on. Okay, so you can use different colors if that helps. I don't know. I think indentation is good. So let's set up for like the product rule. I'm going to just start over here. So remember when we did the product rule, you put what f and g were. F and g. So f is going to be x cubed. G is going to be 2x minus 5 to the 4th. Okay, so everything is peachy here, but then we get to finding the derivative. So the derivative of here, that's going to be 3x squared. Okay, I'm going to use another color for this so you can see. So we need to find the derivative of g. You find the derivative of g by doing the chain rule. So just act like that's not there anymore. Okay? So, u is going to be what's inside the parentheses. And then we have f of u, which, okay, so u is 2x minus 5, so that's going to turn to u to the 4th. By the way, you can use x's if you want. Like, it's going to get confused. You can make that an x to the 4th if you want. It's up to you. Okay? Well, I just put it back into an x after. Okay? Find our derivatives. U prime is 2. B prime of u is 4u cubed. If I put it in terms of x, that's going to be 4, and I'm going to put u in. Okay? So, u is 2x minus 5. Now I'm ready to find the derivative of g. G prime is going to be 2 times 4, which is 8, times 2x minus 5 cubed. Okay? We're ready to do the product rule now. Y equals, and again, notice how I'm indenting things, it just helps. So the product rule is f prime of g plus g prime of f. So that's going to be 8x cubed times 2x minus 5 cubed. Okay. I'm going to be going a step further. Okay. So it's good to get this factoring stuff down. Okay. It just depends on what your book answer, but I'm going to go a step forward. Okay. We're going to factor. We're going to look for greatest common factors. Okay. So of course we see, so let's look 3 and 8. No. X squared, x cubed, yes. So we're going to be taking out an x cubed. I mean x squared, you look for the smallest thing. So x squared. Now, do you see anything else repeating? Yes, you do. You see 2x minus 5 and 2x minus 5. Okay? So act like you have this. This right here. Greatest common factor. You're going to use the expression with the smallest exponent. So this is going to be, so your greatest common factor is going to be x squared times 2x minus 5 cubed. Okay. So watch how we work. So greatest common factor, you go through each term and divide. So 3x squared divided by x squared, that's just going to be 3. Okay. Now you have 2x minus 5 to the fourth and 2x minus 5 cubed. Okay. So you're subtracting the exponents just like you did here. So, yeah. X squared over x squared, that's 1. Or you could do 2 minus 2 is 0. So this is going to be 2x minus 5 to the 4 minus 3 is 1. Okay, that's this term. Now we're going to this term. Plus 8x, so 8. X cubed over x squared is x. And then you have 2x minus 3 cubed over 2x minus 3 cubed. That crosses out. So you get 2x minus 5 to 0, so you get 1. Okay, it looks like that. I'll put a little thing over here. It's going to look like this. So you have 8x cubed, 2x minus 5 cubed, over, here's the greatest common factor, 2x minus 5 cubed. Okay, 8x cubed divided by x squared is x, and then 2x minus 5 cubed, that gets crossed out and equal to 1. Okay, simplify it a little bit more. So we're going to have x squared times 2x minus 5 cubed times 6x minus 15 plus 8x, one more, x squared times 2x minus 5 cubed, 6x plus 8x is 14x. Okay, that is a completely factored chain rule. Alrighty. Okay, so that is that problem. Okay, letter D. So we see something with in a quotient rule. So let's go ahead. So whatever's in parentheses is going to be u. So that's going to be 1 plus x squared over 1 minus x squared. F of u is going to be u to the 14th. Okay. this is done by the quotient rule, okay? Quotient rule. If you can remember, is f prime of g minus g prime of f over g squared. That's the quotient rule, okay? So again, the top is pretty much the same as the product rule. There's just a subtraction sign, and you're over g squared. Okay? So, let's find the derivative. So u prime, so let's go over that. So f, after this lesson, I'm probably not going to be breaking these down. Okay, so f is going to be 1 plus x squared. G is 1 minus x squared. F prime, for the quotient and the product rule, that's what I'm talking about. F prime is x squared, and g prime is, 2x. Congratulations, those who corrected me. You know what you're doing. Okay, g equals 1 minus 2x, so that, or x squared, so that's going to be negative 2x. So u prime, f prime of g, minus g prime of f over g squared. Okay, f. Should have probably brought that over here. Let's bring this over here. Okay. F prime of u is going to be 14u to the 13. And then f prime, if you want to make it in terms of x, that's going to be 14. It's going to look scary. 14. U is this 1 plus x squared. Okay. So, now we get to find the derivative of y. Okay. Derivative of y is going to be u prime times f prime of x. Now let's simplify this a little bit further before we do that. It may help with things. So that's going to be 2x minus 2x cubed plus 2x plus 2x cubed over 1 minus x squared squared. 2x plus 2x is 4x. Those go away. Just might make it easier when we, okay, so this is a simplified u prime. So now I'm going to do u prime times that. So y prime, the big derivative, is going to be 4x over 1 minus x squared squared times 14 1 plus x squared. So I'm going to do it like this because you're going to see something happening. Now you may be asking why I did that. It's because you're multiplying this. You're going to be adding the exponents right here. So 14 times 4 is some number that is going to be 56. 56 x 1 plus x squared to the 13th over 2 plus 13 is 15. And there is your answer. Okay, a little bit more, and then we're done. Well, let's see. Yeah, we're done. So just focus on these for homework. Probably not the same page. Just go to my class. This is 3.6. Okay, in your work, and it's going to be, homework's going to be starting on page 153. Okay, so quick review, and then exercises, and then handout we will do in class. So have fun, work hard, practice, practice, practice. Don't get discouraged, just keep practicing. Okay, have a great day. Bye.